Good morning, friends. Last week we discussed about the reflection by a spherically curved surface, and also we discussed about the lens. Lens has two reflecting surfaces, right? Therefore, there's the ray of the light incident to the lens. So that is the reflected light by both reflecting surfaces. Now, today we are going to discuss about that how the image is formed by a lens. Here we discuss for the convex lens, and that is the most important question. This year there is asked for 4 marks question, long question. Question is that explain the reflection by a thin convex lens. This question is asked. Obtain the lens maker's equation for a thin convex lens with diagram. 4 marks. Now, this question will also ask one step more. For a thin convex lens, obtain the equation of lens. Already we obtained the mere equation for concave and convex mirror. 1 upon u plus 1 upon v is equal to 1 upon f. The same equation. That means the relation between the object distance, image distance and focal length for the lens. This equation is known as the equation of lens. We are going to obtain this thing. Now, before we obtain the answer of this question, first we understand that how the image, final image is formed by the thin convex lens due to the double reflection by the both surfaces. For that purpose, here we consider a thin convex lens. There is the principal axis of a thin convex lens. It has the two surfaces. There is the surface 1, there is the surface. Object is placed on the principal axis of a thin convex lens. Therefore, the ray coming from the object is reflected by the first surface, and its image is formed by the first surface. And this image formed by the first surface act as virtual object for second surface, and hence the final image is formed by the second surface. Therefore, here the reflection takes place 2 times, one for first surface, second for other surface. So here we separately discuss about these 2 surfaces. What are the reflection? And already we discussed about the reflection by a spherical surface, and we obtain the equation minus n1 upon u plus n2 upon v is equal to n2 minus n1 upon n1 upon r. Minus n1 upon u plus n2 upon v is equal to n2 minus n1 upon r. Separately, we apply this equation for surface 1 and surface 2. And then, adding these 2 equations, we obtain the final image by thin convex lens. There is a concept of this answer. For that purpose, the 3 figures required. One is reflection by the surface 1, second is reflection by the second surface, and third is combined. That means the image formed by a thin convex lens. Clear this? Very easy, very short answer, and marks is 4 marks. So most of the students are not write the perfect answer of this question. So be careful about that. Okay. For that purpose here, the figure shows the geometry of formation of the image by a thin convex lens. The final image is formed in 2 steps. That means the reflection by 1 and reflection by second surface. Okay. The image formed by surface ABC is I1 of an object shown in figure A. Here we do the figure. For that purpose, we have considered the spherical surface 1 of a thin convex lens. There is the principal axis. Now, the object O is placed on the principal axis at distance. There is our object distance here. This surface is ABC. Therefore, there is the refraction by the surface ABC. So, C1 is the center of curvature of this surface ABC. Therefore, as we connect the N1 and C. So that is the perpendicular on surface at point N1. Now, the incident ray from object is this. Which makes the angle I1 with the normal at this point. And due to the phenomena of refraction, this ray traveling from a medium, here there is the medium of a lens and the refractive index is N2. N2 is greater than N1. So after refraction, this incident ray or the refracted ray bends towards the normal and meet at point I1. So I1 be the image of point-like object formed by ABC surface. Now here BC1 there is our R1, and now BI1 there is our image distance V1. There is our image distance V1. Here the ray of light is going from there to the denser medium. Therefore, we are using this equation minus N1 upon U. Here U is our OB distance plus N2 upon V. V is BI1 distance is equal to N2 minus N1 upon R. R is equal to BC1. Okay. Therefore, from equation of refraction by a spherical surface we can add directly from this minus N1 upon OB plus N2 upon BI1 is equal to N2 minus N1 upon radius of curvature, that is the BC1, equation 1. Now, we are trying this equation for second surface. For second surface, whatever image formed by the first surface, that is the I1. This I1 acts as a virtual object for second surface. This image I1 act as a virtual object for second surface or the surface there is a ABC and final image I is forward. For that purpose, the video diagram into this manner. There is the principal axis. Already the I1 is forward here. And already our C1 is here. And now for this spherical surface, there is the ABC. Center of curvature is this C2. Here we consider one more point, that is the N2. Now N2 C2, there is a normal. whatever the ray, that is our incident ray that is coming from our image formed by the ABC. So that is our angle of incidence I2. There is our I1. So actually I1 is not in this side, I1 is between the medium. Here the image formed by the first surface is here, and then this acts as a virtual object, and therefore the ray coming from I1 is this, and final image I is formed. So this ray is reflected in this direction, and I is formed here. This final image is formed. Therefore, our DC2 radius of curvature for second spherical surface, DI, that is the final image, and now DI1, that is the object distance for ABC surface, that is the here the left hand side of ABC surface, here the effective index is N2. Here the effective index is N1. Here N2 is greater than N. N2 is greater than N. Therefore, we are applying this equation. Therefore, for ABC surface, we can add here minus N2 upon V1. V1 is this DI1. DI1 plus N1. N1 is equal to what? N1 is the effective index of this medium, air medium, in which the image is formed, upon DI is equal to N2 minus N1 upon radius of curvature. That is the DC2. That is the equation number. Here we have this equation same as for the ABC, the same as for ABC surface. But here the effective index of the medium is C. Here N1, this side N2, here this side N1, this side N2. Now keep in mind that in I1 is not this side, actually the I1 is this side. In N2, then here. Okay. So that is the equation 2. And final image formed by the thin convex lens is shown by the third figure. That is our next. So as we combine the both surfaces, so what is the final figure? So final figure is that the final image formed by thin convex lens is shown in figure. Figure C. There is a figure A. There is a figure B. And there is a figure C. For that purpose, here we do a thin convex lens. There is the principal axis. The object is here. What is the object? So final image I is formed here. There is the surface 1, surface 2, or ABC, or an ADC. Here the C2, here the C1. OB is our object distance, DI is our image distance. Okay. So from figure, now what is the BI1? BI1 and DI1 are same. There is the I1, so there is another B1. Why the BI1 and DI1 are same? Because here the lens is very thin. And in case of a lens, we can measure the distance from any reflecting surface for a thin lens. Now listen, remember for mirror, we measure all the distances from pole of a mirror. But here the two surfaces of a lens, therefore, we can measure the distance from any reflecting surface. Generally, we consider it's a optical center, that means the midpoint of the reflecting medium. But we can also measure the distance from any surface, therefore BI1 and BDI1 are same. Now, adding equation 1 and 2. So by adding this to equation 1 and 2, we obtain the final image. Therefore, minus N1 upon OB plus N2 upon BI, here minus N2 upon DI1 plus N1 upon DI is equal to, now from these two, N2 of minus N1 is common. Remaining is 1 upon BC1 plus 1 upon BC2. 1 upon BC2. 1 upon BC2. Okay. But BI1 is same as the DI1. Therefore, these two are cancelled for a thin lens. For a thin lens. Therefore, minus N1 upon OB plus N1 upon DI is equal to into minus N1 into 1 upon BC1 plus 1 upon BC2. This is the expression. Now, if object is at infinite distance, therefore OB is equal to infinite. So its image is formed on the principal focus. Therefore, DI1 or the DI is equal to F. Therefore, minus N1 upon infinite plus N1 upon F is equal to N2 minus N1 here. BC1 is our I1, BC2 is our I2. Here there is the 1 upon I1 minus 1 upon I2. Because here we substitute BC1 as I1 and BC2 as minus I2 with the sign convention. Because the BC1 is in this direction, is in the same direction of incident ray, therefore I1 is positive. While the DC2 is in opposite direction of incident ray, therefore that is considered negative. Therefore, take the N1 in this side, 1 upon F is equal to N2 minus N1 upon N1 into 1 upon I1 minus 1 upon I2. That is equation number. This is the lens maker's equation. This equation is the lens maker's equation. This is lens maker's equation. Why there is the lens maker's equation? Because by using this equation, we can prepare the lens with our desired frequency. How? Here the I1 and I2 are the radius of curvature of a lens. As we take the proper radius of curvature of the both surfaces, so we can prepare the lens with our required focal length. And therefore, this equation is known as lens maker's equation. So this question is asked in 4 marks in this year. So actually very easy but quite lengthy. Here the 3 figure, each figure has the half marks. So half marks, half marks, half. So 1.5 marks of this 3 figure. So this three figure must be compulsory to draw it. If you not draw the any one figure, so here the half mark is here. Clear this? So very easy. So you have to write down one or two times, so you can easily prepare it. For thin convex lens, so up to this you get the answer, the lens maker's equation. Now, we are going to discuss about that, how to obtain the equation of lens. Clear? After having the equation, lens maker's equation, we are going to obtain the equation of lens. That means the relation between the object distance, image distance, and radius of curvature and refractive indices of a given lens. Okay, how we obtain it? Therefore, in a thin convex lens, the reflection takes place by the both for the two spherical surfaces, and we obtain the equation 3. Equation 3 is that minus n1 upon OB plus n1 upon DI is equal to n2 minus n1 into 1 upon I1 minus 1 upon I2. Actually, there is the 1 upon BC1 plus 1 upon BC2. Here, with using the sign convention, we substitute the value of radius of curvature. Now, what is the OB and what is the DI? OB is object distance, DI is equal to image distance. Final image is formed at DI distance. Therefore, substitute OB is equal to U and DI is equal to, here we are not considering the sign convention, keep in mind that, because when we derive this equation minus n1 upon U plus n2 upon V is equal to n2 minus n1 upon R. That means there is the equation of spherical reflection by spherical surface. At that time we use the sign convention. Therefore, again, we are not using the sign convention, we only substitute the value of OB and DI as U and U. Therefore, minus n1 upon U plus n1 upon V is equal to n2 minus n1 upon n1, here 1 upon I1 minus 1 upon R2. Separately, substitute n1. Therefore, n2 upon n1 minus 1, that is known as the n2 1 into 1 upon I1 minus 1 upon R2. That is equal to, just me. Here from this equation we take the n1 common. Therefore, n2 minus n1 upon n1 here. And here the n1 is taken common, minus 1 upon U plus 1 upon, separately we substitute the n1. So this equation becomes n2 upon n1, that is the n21 minus 1. Here 1 upon I1 minus 1 upon I2. That is a minus 1 upon U plus 1 upon. There is our equation number 1 directly. For this equation in terms of the object distance and image distance, directly we obtain this equation. Reflection by the two spherical surfaces of a lens. And lens maker's equation. Lens maker's equation is, there is the 1 upon F is equal to n2 minus n1 upon n1. And here 1 upon R1 minus 1 upon R1. There is also written as n21 minus 1. Here 1 upon R1 minus 1 upon R2 equation. Here we can mention as the n21 is equal to n2 upon n. Now in equation 1 and 2, in equation 1 and 2, the right hand side are same, therefore we have to compare the left hand side. Therefore, minus the comparing equation 1 and 2. So we obtain minus 1 upon u plus 1 upon v is equal to 1 upon f. And also we know that here the 1 upon f. So that is the relation between the object distance, image distance and focal length of a lens. So this equation is known as equation of lens. This equation is valid for both type of the lens, either the convex or the concave. This equation is valid for both lens, convex and concave lens. So there is the equation of lens after the lens maker's equation. So there is the equation of lens we can obtain by accepting this. So instead of the lens maker's equation, sometimes the 4 marks combined equation is asked. Explain the refraction bias theoretically or the thin convex lens and obtain the equation of lens. So for this you have to write down the answer. After the lens maker's equation, one more step, you have to write down this. There is also possibility for 4 marks question. Clear?